Hello and welcome. In this video tutorial, we're going to take a look at Part 4 Metric Conversions from our Physics Math Review. Remember to please pause or rewind the video as necessary. Let's begin. Science uses the KMS system, or SI System International, or International System of Units. KMS is an acronym that stands for kilogram meters second. These are the base units that are used in physics. The equations in physics depend on unit agreement, so you must convert to KMS to solve problems to arrive at the correct answer. In front of you, I've put together something called the metric staircase. Here's how it works. Metric system conversions are based on factors of 10. When you multiply by 10, you simply move the decimal place to the right. When you divide by 10, you move the decimal place to the left. And that's essentially what we're doing when we change from one metric unit to another. We either multiply or divide by 10. Now, the staircase is designed for each factor of 10. So every stair you go up is one movement of the decimal place to the left. Every stair you go down is one movement of a decimal point to the right. Again, only the decimal point changes, not the values of the number. We also have a table here showing the multiplication factor that goes with each metric prefix. Okay, note, for example, if we had 3 kilometers, we could write that as 3, looking up kilo right here, 3 times 10 to the 3 meters. So in other words, I can simply tack on and replace the metric prefix of kilo with its numerical multiplication factor of times 10 to the 3. And that's a very easy way to change it as well. Okay, another example I might see would be, let's say I saw something that said 5.5 millimeters. I could replace milli with times 10 to the negative 3, right? And it's 5.5 times 10 to the negative 3 meters. So simply replacing milli with its multiplication factor. So there are two ways to make these changes. One is to use the table of multiplication factors. Two is to what I call taking the stairs. Taking the stairs refers to going up or down the stairs and moving the decimal place accordingly. Let's take a look and practice this. In letter A, you have 4,008 grams and you want to convert that to kilograms. Okay, here's how we do that. Grams is here in the middle staircase, right here. And you want to go up to kilo. In order to do that, you have to go up 1, 2, 3 stairs to the left. Well, what that's going to do is that's going to correspond to 3 movements of the decimal point to the left. The decimal point in 4008 is right here at the end. If you don't see it, it's assumed to be at the end of the number. And we're going to move it over 1, 2, 3 places to the left. And 4,008 grams now becomes 4.008 kilograms. Notice the digits did not change. The only thing that changed was the point, the decimal place. All right, letter B, I'm going to show you 2 ways. If we take the stairs, we're going to go from kilometers to meters. Kilo is up here. Regular meters is down here. So we're going to go down 1, 2, 3 stairs, which means going down the stairs is moving the decimal to the right. So I would go 1, 2, 3, put in a couple 0 placeholders, and I get 1,200 meters. So 1.2 kilometers is 1,200 meters. Or another way we could do this, I could write it like this, or I could use the metric multiplication factor and just simply put 1.2, replace kilometers, replace kilo with its numerical factor, which is times 10 to the 3. And this is equivalent to this. So you have two ways. When you start with a metric prefix, you have two ways of converting that. Okay. Letter C. 823 nanometers. All right, now nano on the staircase is really hard to find because it's actually way, way down here. It's actually 3 stairs down from micro, okay? And so taking the stairs is not really going to be too much of an option for super small metric prefixes. So nano has a numerical equivalent of times 10 to the negative 9. So we're going to start by replacing this, and this is going to be 823 times 10 to the negative 9. Notice, ladies and gentlemen, all I did was replace the nanometric prefix with the number that it stands for. 823 stayed the same, right? But that's not proper scientific notation. So I'm going to take the decimal, and I'm going to move it 2 places to the left to make it proper. But once I move the decimal, I have to move the exponent accordingly. So this becomes 8.23 times 10 to the negative 7. You move closer to 0. When you move the decimal point to the left, your number becomes more positive. When you move the decimal point to the right, it becomes more negative. Let's see, letter E. We have 0.77 meters is how many centimeters? Okay. Meters is right here. Centi is here. You're going to go down 2 stairs, which means you're going to move the decimal point 1 twice to the right. 0.77 meters is 77 centimeters. Okay, letter F. 8.8 times 10 to the 8 meters is how many millimeters? Well, again, I'm going to show this to you by taking the stairs. So to go from meters right here to millimeters, you got to go down 1, 2, 3 stairs, because millis all the way down here. So this becomes 1, 2, 3, or 8,800 times 10 to the negative 8. Now that's 8,800. That's not proper scientific notation. Proper scientific notation has the decimal in between the first 2 digits. So I got to take that decimal point, which is hanging all the way back over here, and I got to move it 1, 2, 3 points that way. And if I do that, my exponent becomes a little more positive, 3 factors of 10 more positive. So 8.8 times 10 to the negative 5. Letter H, I'm going to replace this as 25. This little symbol right here is the Greek letter mu, and you can see it stands for micro, which is times 10 to the negative 6, really small. So this would be the same thing if I replace the micro. This would be the same thing as 25 times 10 to the negative 6 meters, right? And if I take the decimal and move it appropriately 1 space over, that changes the exponent by 1, making it 1 more factor of 10 positive. So 2.5 times 10 to the negative 5 meters. 2.65 millimeters is how many meters? Milli is down here. I'm going to go up 1, 2, 3. Notice I never start on the staircase that I'm originating from. I always start on, of course, the next one. So I moved up 3 stairs, which means I moved the decimal point to the left 1, 2, 3. And 2.65 millimeters is 0.00265 meters. 8.23 meters is how many kilometers? To go from meters to kilometers, you have to go 1, 2, 3 stairs up, which will move the decimal point 1, 2, 3 points to the right, put in 2 zero placeholders, and this would be 0.008 823 kilometers. Letter J is probably the most common measurement you're going to make first semester, and that's converting centimeters to meters. To do that, you have centimeters. We're going to go up 2 stairs to get to meters, which means you're moving the decimal point twice to the left. So 40 centimeters is really 0.40 meters. And letter K, 1.5 times 10 to the 11 meters is how many kilometers? Well, we saw that going from meters to kilometers, you have to go up 1, 2, 3 stairs to the left. So that means the decimal gets moved 3 places to the left. So 1, 2, 3 with a couple 0 placeholders. So you have 0.0015 times 10 to the 11. But again, that's not proper scientific notation. We have to move that decimal from here all the way over there in between those 1 and 5. So to do that, I'm going to move the decimal 1, 2, 3. But that is going to now make that one a little bit smaller. And this becomes 1.5 times 10 to the 8 kilometers. We move this, we drop this 3 factors of 10. All right, I hope you found this video tutorial helpful. Please rewind as necessary. Thank you.